Sorting and searching algorithms. We will divide this course into two parts. The first part is the sorting algorithm, and we will introduce the bubble sort algorithm, select sort algorithm, and insertion sort algorithm in order. The second part is the search algorithm. We will introduce the linear search algorithm and the binary search algorithm in order. Does anyone know which algorithm is most commonly used in daily life? The answer is sorting algorithm. Such as checking invoices to win a prize to efficiently and accurately match the numbers to win. When sorting height and weight, how to efficiently find out the target who is tall, short, fat, thin, or meet your requirements. In addition, when ranking the results, how to efficiently find out the good and bad results and judge the grades. All these are the applications of a sorting algorithm. So, let us first understand what sorting is. Sorting refers to a change in the position for a group of data based on specific rules, such as increasing or decreasing for the data to have a certain order relationship. In a group of data records, the sorting can be done for a certain field. This field is called the key. We call the value in the field the key value. The sorting algorithm has many ways of sorting, which can be divided into internal sorting and external sorting, according to the different ways of storing data. Internal sorting refers to a small amount of data that can be sorted in the memory. Generally speaking, most sorting algorithms are internal sorting. External sorting refers to a huge amount of data that cannot be sorted in memory and needs to be assisted by other storage devices. External sorting usually will load parts of the data into the memory in batches after being sorted by internal sorting algorithm, and then the results are stored or merged. In addition, it can be divided into direct movement and logical movement according to different ways of moving data. Direct movement is directly exchange the location of the stored data. However, logical movement does not move the storage data location. It only changes the value of the auxiliary indicator pointing to these data. In addition, we can classify according to the stability of sorting. Stable sorting happens when, after the data is sorted, two records with the same key value still maintain the original order. Such as in this example, the original position of the 30 left is on the left side of the 30 right of 30. After stable sorting, the 30 left should still be on the left side of the 30 right. On the contrary, after an unstable sorting, the 30 left may go to the right side of the 30 right. Sorting algorithm can help us sort data according to requirements. The sorting process will involve memory space, stability, and efficiency. So, how do we judge the efficiency of a sorting algorithm? In the process of sorting, the number of exchanges of data and the number of comparisons can be used to judge the efficiency of an algorithm. This criterion is called time complexity. However, every time the sorting algorithm is used, the situation is different and the number of calculations or comparisons is different. How do we count the number of exchanges or number of comparisons? Let's take a look at the situations that may be encountered when sorting. Best case. Assuming that the original data has been sorted in descending order, at this time it only takes time to traverse all the data once, and this is the best case. Average case. The average case refers to the case when the average amount of calculation is performed by the algorithm. Simply put, it is the average execution time of all cases from case 1, case 2 to case n. Worst case. It refers to the case in which each key value must be rearranged. For example, if it was originally sorted in increasing order, it needs to be sorted in decreasing order. Of course, it will take a longer time. Therefore, unless otherwise specified, the time complexity we mentioned is the worst case time complexity. Then, let us take a look at what the common sorting algorithms are. Bubble sort. The bubble sort is also known as the exchange sort. It is conceived by observing the changes of bubbles in the water. Starting from the first element, compare the sizes of neighboring elements. If the size order is wrong, swap the places and then compare the next element, as if bubbles are rising from the bottom of the water to the surface. Let us look at some examples. Use bubble sort to arrange the 5 numbers of 55, 23, 87, 62, and 16 in ascending order from small to large. This is the original value. According to the meaning of the question, we want to arrange the numbers in ascending order. So after sorting, it will be arranged from small to large. The bubble sort algorithm compares the sizes of adjacent elements in order, so if the number on the right is not larger than the number on the left, just swap. In the first scan, compare the first element 55 with the second element 23. 55 is larger than 23, so swap and let 55 be on the right. Next, compare the second element 55 with the third element 87. 55 is smaller than 87, no swap is necessary. Compare the third element 87 with the fourth element 62. 62 is smaller, swap places with 87 to stay on the left. Compare the fourth element 87 with the fifth element 16 and swap 16 to the left. At this time, the last element 87 is the maximum value of the array. We have compared n-1 times in the first scan, which is 4 times, and the second scan will start the comparison from the beginning. But because the last element has been determined to be the maximum value of the array, so it only needs to compare 3 times to arrange the maximum value of the remaining array element to the last place of the remaining array. Then let us continue to compare. In the second scan, we only need to compare 3 times. First time, 23 and 55, the order is correct, keep it as it is. Second time, 55 and 62, the order is correct, keep it as it is. Third time, 62 and 16, swap the order. Confirm that 62 is the maximum value of the first 4 elements. A total of 3 comparisons. This scan only needs to compare twice in the third scan, and confirms that the third item is 55. In the fourth scan, this scan only needs to be compared once. This is also the last comparison to confirm 16 and 23. Scan is completed. It can be known from the above process that if an array has n elements, it needs to scan n-1 times. This time there are 5 elements, so 4 scans are required. In addition, the number of comparisons in each scan will be less and less. The first comparison is n-1 times, the second comparison is n-2 times, until the last scan comparison is 1 time. Let us take a look at the reference programming code. First of all, we set up the array of placing the original data in the show data. Use the for loop to set the scan times. 5 data items, so scan 4 times, I equals 4. Then it is the part of comparison and the number of swaps. If data j is larger than data j plus 1, then swap. The last part shows the sorting results of each scan and the final sorting results. Then the execution result will be like this, clearly listing the results of each sorting. Next, let us analyze the bubble sort. We can know that the bubble sort algorithm of n elements must perform n-1 scans. Both the worst case and the average case need to compare n times n-1 divided by 2 times. The time complexity is n squared. The picture on the right is to visualize the bubble sort data convergence. After continuous comparison, it will be confirmed item by item from the end. Bubble sort is suitable for a small amount of data or some data has been sorted. And because the 2 adjacent ones are compared and swapped with each other, so the bubble sort algorithm does not change the order of its original arrangement and is a stable sorting algorithm. Let us practice it. Please put the unsorted sequence of the numbers 43, 35, 12, 9, 3, 99 into a one-dimensional array. Use the bubble sort algorithm to sort from small to large in ascending order and display each sorting and the result after sorting. Output description. Output the results after each sorting separated by spaces in between. Finally, output the final sort result separated by spaces in between. Program practice. Stored in a one-dimensional array, write the programming code with C, C++. Output example. Refer to the previous example teaching. The output format is as shown on the screen. Let us practice and see what the results will be after the first sorting. It should be 35, 12, 9, 3, 43, 99. The second time is 12, 9, 3, 35, 43, 99. The third time is 9, 3, 12, 35, 43, 99. The fourth time is 3, 9, 12, 35, 43, 99, and the sorting is completed. For the part of programming code, I will let you give it a try. Select sort. The select sort algorithm uses loops to repeatedly take out the smallest element from the unsorted sequence of numbers, sequentially swaps with the elements in the sequence, and finally obtains the sorted sequence of numbers. Its advantage is relative to data movement. If an element is in the correct final position, it will not be moved. Use the select sort algorithm to arrange the 5 numbers of 55, 23, 87, 62, and 16 in ascending order from small to large. Let us scan. The arrow indicates the element that will be swapped, starting from the first element 55. First of all, find the minimum value of this sequence of numbers except 55, so we swap 16 with the first element 55. In this scan, a total of n-1 times will be compared, which is 4 times. Then perform the second scan. Lock the second element 23 that will be swapped. Find the smallest value of the remaining values in the sequence of numbers and swap with the second value. Because 23 is the smallest, so there will be no need to swap this time. In this scan, it will compare n-2 times in total. Perform the third scan to find the minimum value 55 that does not contain the first and second elements in this sequence of numbers. Let us swap 55 with the third value 87. In this scan, it will compare n-3 times in total. The last scan locks the fourth element, 62, that will be swapped, because there are only 2 elements, 62 and 87, left. After the comparison is found that the size order is correct, so there's no need to swap. In this scan, a total of n-4 times have been compared, which is once. After swapping the n-1 element in the array, the arrangement of the numbers from small to large is completed. At this time, we scan 4 times in total. Let's take a look at the reference programming code. The first is to declare the select and declare the function of show data. Next, put in the original data to be arranged and the corresponding show content. This programming code is to set the blanks between the numbers of the original data using the method of putting blanks before each data. Number of scan, 4 times. Let the position start from I. Use the for loop to find I plus 1, which is j, compare the data of posts and j. If the data of j is smaller, point the data of j to the position of posts. If the data of j is larger, keep it unchanged. Now the data stored in posts is the minimum value, so we swap the data of I and posts. The last step is the output. Analysis of select sort. The select sort algorithm with n elements, whether it's the worst, best, or average case, the maximum or minimum value needs to be found. So the number of comparisons of the select sort algorithm is n-1 plus n-2 plus n-3 plus 3 plus 2 plus 1 equals n times n-1 divided by 2. Time complexity is n squared. The picture on the right is to visualize the select sort to find the maximum or minimum value, and we can sort in order from the lower left corner. Select sort is to swap the largest or smallest value directly with the unsorted key value at the front. The data sorting order is likely to be changed, so it is unstable sorting. Let us practice. Please put the unsorted sequence of numbers 43, 35, 12, 9, 3, 99 into a one-dimensional array. Use the select sort algorithm to sort in ascending order from small to large and display the result of the previous 3 sorts. Output description. Output the results after each sorting separated by spaces in between. Finally, output the final sorting results separated by spaces in between. Program practice. Stored in a one-dimensional array. Write the programming code with C, C++. Output example. Output the original data, the results after each sorting, and the final sorting results in order. The first sorting will be to swap the smallest value of the last 5 numbers with 43. So it will be 3, 35, 12, 9, 43, 99. For the second time, 3 does not move. select the smallest 9 in 12, 9, 43, 99 to swap with 35 to become 3, 9, 12, 35, 43, 99. Have you found that the sorting has actually been completed from small to large? But the program will continue to compare, so the third order is also 3, 9, 12, 35, 43, 99. In addition, there will be a fourth sorting. For the program, after all, it must run all the steps to know whether the sorting is correct. Now try to practice the programming code. Insert sort. The insert sort algorithm compares the elements in the array with the sorted data one by one. For example, the first two elements have been sorted, and then insert the third element into the appropriate position to become part of the sorted data. Repeat this step until the sorting is complete. Use the insert sort algorithm to arrange the 5 numbers of 55, 23, 87, 62, 16 in ascending order from small to large. Step 1. Take out the first element 55 in the array and place it. Step 2. Also take out the second element 23, and after the size comparison with the previous 55, swap the positions. Step 3. Take out the third element 87, and compare it with the previous 55 and the 23 before it in order. However, because 87 is larger than 55, so place 87 behind 55, it will actually not compare with 23. Step 4. Take out 62 and compare it with 87. 62 is smaller, so place it on the left of 87. 62 is larger than 55, so insert 62 between 55 and 87. Step 5. Take out 16. 16 is smaller than 87, 62, 55, and 23, so insert it before 23. Go through 4 times, that is, n-1 comparisons to complete the insert sort. Here is the reference programming code. First of all, define the size of the array and declare the insert sort algorithm insert, declare the show data, and declare the input array. Store the data in the array and show the original array. The input array function uses the for loop to input the 5 elements, to be arranged and display text. The show data function will show the input data in order and insert a space before the data. The insert function is to perform insert sort algorithm. There are temp that temporarily stores the I data and j, the previous item of I. The while loop will help us compare the size of the array elements and continuously compare with the previous element to perform sorting. This is the reference output of the programming code. Analysis of insert sort. The insert sort algorithm with n elements, in the worst case, the number of comparisons is 1 plus 2 plus 3 plus n-3 plus n-2 plus n-1 equals n times n-1 divided by 2. The time complexity is n squared. The picture on the right is to visualize insert sort, and it can be seen that the insert sort will continuously shape the sorted appearance during the sorting process. For insert sort, because the sequence of equal elements does not change during the insertion process, so the insert sort is a stable sorting. Please put the unsorted sequence numbers of 43, 35, 12, 9, 3, 99 into a one-dimensional array. Use insert sort to sort ascending from small to large, and display the process and results of the sorting. Output description. Please output each input element, original array, and the results of 5 scans according to the format. Please use a space to separate the original array and the result of the final sorting. Program practice. Stored in a one-dimensional array, write the programming code with C, C++. Output example. This output example is more complicated. Please pay more attention. So, let's practice and think about the results of each scan. The first scan will get 35, 43, 12, 9, 3, 99. The second scan will compare 12 with the previous number to get 12, 35, 43, 9, 3, 99. The third scan will compare 9 with the previous number to get 9, 12, 35, 43, 3, 99. The fourth scan will get 3, 9, 12, 35, 43, 99. The last scan is also 3, 9, 12, 35, 43, 99. Did you notice? The compared numbers will be inserted into the sorted sequence. For the programming code part, please give it a try. Let's put the 3 sort algorithms that we just learned so far in order. From this table, we can know that in general, the efficiency of these 3 algorithms is similar. It is worth noting that only the select sort algorithm is an unstable sort algorithm, and both the insert sort and the bubble sort algorithm are stable sort algorithms. Sort algorithm, input interface. Please design an interface that allows users to input with the 3 functions including bubble sort algorithm, select sort algorithm, and insert sort algorithm. Let the user enter 10 numbers at random. Sort the numbers from small to large, and output the result of every sort. Input description. Input the following 10 numbers in sequence: 34, 12, 56, 21, 5, 7, 88, 19, 73, 25. And store into the array data structure. Use the menu to perform different sorting algorithms. Output description. After outputting the different sorting with different sorting algorithms, the values in the one-dimensional array are separated by commas. Calculate the number of data swapping required for different sorting algorithms. Search algorithm. Search refers to the action of finding records that meet certain conditions from a group of data records. In addition, the condition used for search is called the key value, just like the key value we mentioned in the sorting algorithm. Search algorithm is a very basic concept in computer science. The search engines such as Google and Yahoo that we use to find information on the internet every day are quite proficient in applying search technology. Data search can be classified according to several methods, such as if the data table is classified based on whether it has changed during search. It can be divided into static search and dynamic search. Static search refers to the data table that will not have any additions, deletions, or updates during the search process. For example, looking up a paper dictionary or phone book is a static search. Dynamic search refers to the fact that the data table frequently changes during the search process. In addition to whether the table is changed or not, we can also classify according to the amount of data. Search as internal search and external search. Internal search involves less data to be searched, which can be directly loaded into the memory for searching. The external search means that there are more data to be searched, which cannot be loaded into the memory for searching at one time. And an external auxiliary memory needs to be used for batch processing. The main core action of search is comparison, and the main topic is how to search quickly. Linear search. The linear search algorithm is also called a sequential search algorithm and is usually used for unorganized files. The linear search algorithm searches a group of data from the beginning to the end until the data is found. Let us look at how the linear search algorithm works. Search for 16 in the sequence of numbers 55, 23, 87, 62, 16. Using the sequential search algorithm to find the position of an element is very simple, as long as all the elements in the array are compared. Therefore, if there are n elements in the array, it will need to compare n times at most. If the data is not repeated, it can be terminated when the data is found. In the case of n data, the worst case requires n comparisons. The best case is 1 time. In average cases, it is required to do n plus 1 divided by 2 comparisons, so the time complexity is n. The advantage of the linear search algorithm: the data is not required to be sorted or processed in advance and is suitable for various applications. The disadvantage of the linear search algorithm: the efficiency of the search is poor and it needs to be searched from the beginning to end regardless of whether it is sorted or not. Let us take a look at part of the programming code. The programming code of the linear search algorithm is very intuitive. That is to use a for loop to determine whether all the elements in the array are equal to the element to be found. To complement the programming code more completely, first declare the function of linear search. Declare 3 variables: search, answer, I. Define an array named data to store our original data. and set it to show the original data and the data to be searched. Call the linear search function. The answer returned by the function will be stored in answer. If the data of answer is smaller than 0, it will display data not found. Otherwise, it will display the number row where the data was found, and the data itself will be searched. Here is the content actually executed by the linear search function. Use the for loop to search one by one. The output example will be like this. If the data 55 does not exist in the array to be searched, and the data 44 exists in the array, it will look like this respectively. Binary search. Binary search algorithm, also known as half-interval search algorithm or logarithmic search algorithm. As the name implies, the array will be repeatedly divided into two equal parts, which can perform a highly efficient search in the sorted sequence. The binary search algorithm does not need to judge the elements in the set one by one, because the set it searches must be a sorted sequence. So the size of the element can be directly used to determine the position to be searched next time. Searching for elements in a sorted sequence is very easy. We can first set the search range and use the middle element of this range to compare the size of the target element to be searched each time. Assuming that the target element we are searching is relatively large, it means that if the target element exists in the sequence, it must be in the second half of the current range. That is, the segment with the larger value. On the contrary, if the target element to be searched is relatively small, it means that the target element exists in the sequence. It must be in the first half of the current range, the segment with a smaller value. During the next search, continue to compare the target element with the middle element in the first or second half segment, and repeat the action until the same element is found, or until there is only one element in the search range. It means the element we are searching for does not exist in the sequence. Search for 11 in the sorted series below. First of all, we first find the element 9 in the middle of the array, and compare the value we are searching for with 9, because 11 is larger than 9. So the next step is to compare with the second half of the array. So divide the array into two parts. Then compare with the value in the middle of the divided array. In this example, we take 12. Because 11 is smaller than 12, after dividing the array this time, compare it with the median value 11 in the first half of the array. In the third step, because 11 is equal to 11, the search is now complete. If there is only one value left in the array, but it is not equal, it means that it cannot be found. So everyone has an idea about the binary search algorithm, right? Before introducing the time complexity of the binary search algorithm, let's review the logarithm first. Logarithm is the inverse operation of exponentiation. Assuming x equals a to the b, means b equals log base a of x. Example, a equals 2 to the power of 3 is 3 equals log base 2 of 8. When we want to find out how many times 4 must be divided by 2 to equal 1, we can use log base 2 of 4 to indicate that 4 needs to be divided by 2 twice to be equal to 1. Because every search will be half of the range less than the previous one, you only need to compare log base 2 in, rounded up, or log base 2 n plus 1 rounded up times. The time complexity is log n. Let's take a look at the programming code. Because the binary search algorithm divides the array into two equal parts, therefore, we first add index values representing the beginning, end, and middle elements of the array. Then use the while loop to execute the binary search process. The condition for the end of the while loop is low is larger than high, which means that the element to be searched for is not found in the array. Set the mid value to the half low plus high, which means dividing into two halves. If the value to be searched is smaller than the middle element of the array, set the index value of the last element of the array to the index value of the middle element of the original array. If the value to be searched is larger than the middle element of the array, set the index value of the first element of the array to the index value of the middle element of the original array. If it is other cases, it means that the middle element mid of the array is equal to the value to be found. To complement the programming code more completely, first declare the function of binary search. Declare the variables, search and answer. Define an array named data to store the original data we have sorted, and set the content of showing the original data and the data to be searched. Call the binary search function, and the answer returned by the function will be stored in answer. If the data of answer is smaller than 0, display the data that cannot be found and the related text. Otherwise, display where the data is found and the data itself. Here is the actual execution content of the binary search function. Use the while loop with a condition judgment to continuously divide the array in half for comparison. The output example will be like this if searching for data 55 that does not exist in the array. Moreover, the data 44 that exists in the array, it will look like this respectively. Do-it-yourself search algorithm. Write an interface for users to input. The functions are as follows. 1. Build an array of size 10. 2. Input a number and use the linear search algorithm to search whether there is this number in the array mentioned above, and if there is, print the position in the array. 3. Sort the array using bubble sort algorithm. 4. Input a number and use the binary search algorithm to search whether there is this number in the above array. If there is, print the position in the array. Key point review. Sorting refers to a change in position for a group of data based on specific rules, such as increasing or decreasing, for the data to have a certain order relationship. In a group of data records, the sorting can be done for a certain field. This field is called the key. We call the value in the field the key value. The sorting algorithm has many ways of sorting, which can be divided into internal sorting and external sorting according to the different ways of storing data. The sorting process will involve memory space, stability, and efficiency. Search algorithm. Search refers to the action of finding records that meet certain conditions from a group of data records. In addition, the condition used for search is called the key value, just like the key value we mentioned in the sorting algorithm. We can also classify according to the amount of data, search as internal search and external search. Internal search involves less data to be searched, which can be directly loaded into the memory for searching. The external search means that there is more data to be searched, which cannot be loaded into the memory for searching at one time. Moreover, an external auxiliary memory needs to be used for batch processing. The last part is the reference information. There is a book here, Graphic Illustration of Algorithm, which uses the C++ language. Find it and read it if you can. And the resources on the internet covering all kinds of algorithms. There are complexity analysis, bubble sort algorithm, select sort algorithm, insert sort algorithm, linear search algorithm, and binary search algorithm. Everyone, please try to learn more about them. Let's take a look at the bubble sort algorithm in sorting and search algorithms. This question expects us to use the bubble sort algorithm to sort the 5 numbers of 55, 23, 87, 62, 16 in ascending order from small to large. Then how to write the programming code for bubble sorting algorithm? First of all, let us process all the formats. After the basic format is complete, we need to sort these 5 numbers, 55, 23, 87, 62, and 16. So we first built an array of data and put these 5 numbers into it. Next, let's do the sorting. So, how do we do the sorting? In the beginning, we can display a prompt text showing that this one is sorted with bubble sort. Here you can see that there is a \n. Let's execute it to see what this means. Okay, when I was typing, I missed an M. The \n here means a new line. So when we display it, it will display the bubble sort algorithm. Then the original data of the new line is like this. Or you can directly output the bubble sort algorithm. You can also use ENDL to create a new line directly. Next, because we want to show the original data, that is, the 5 data of 55, 23, 87, 62, and 16, so we use a for loop. Use the for loop to show these 5 data. That's because we only need one line, so with or without parentheses, it is up to you. After it's done, we will do a new line after that, so that each row will not have only one number. Let's execute it again. This way, after the original data, we can show our data. The next step is the time we're actually going to sort. How to do this bubble sort algorithm? The bubble sort algorithm basically uses 2 loops. One of the loops is controlling the number of times it wants to sort. So this loop outside is simply controlling the number of times. For 5 data, we need to sort 4 times. So for this one, we just let it make 4 moves. The next loop is really controlling how our bubble sort algorithm should proceed. The spirit of the bubble sort algorithm is to combine 2 adjacent data, compare and sort by the size, and that is it. Because every time the following data will be sorted, therefore, every time we need to compare, the number of comparisons will be less and less. So here, j can be used as smaller than I. In the beginning, we compare from the first to the last. After the first time is done, the last one will be done sorting. So for the next time, we only need to compare from the first to the second one from the end. Then the next time, it is from the first one to the third from the end, slowly getting less and less. And every comparison is to look at 2 adjacent items, so we just look at j and j plus 1. Look at their size relationship. Which one should be put in the front and which one should be put in the back? Then which one should be put in the front and which one in the back? It depends on whether you want to sort from large to small or from small to large. The question is for us to sort from small to large. So we just put the large one in the back. Then we see that the one in the front is larger than the one in the back. Just swap the position, put the large one in the back. When swapping, trigonometric substitution can be used. First, set up a variable of temp to store the one in the front. Then put the data in the back in the position in the front. Finally, put that data just temporarily stored in temp in the position in the back. If you didn't write it this way, just write data j equals data j plus 1. Then if data j plus 1 equals data j, your data will be messed up because it might become, suppose we are 55 and 23, data j equals 23, then the next position in the back, it will also be equal to data j just now, and it will be changed to 23. Then data j plus 1 is still 23. That will become 23 and 23 instead of 2355. So pay special attention here and be careful not to swap them wrong. That's because we want to output the items every time in the process. So we have to start outputting in the loop. We just look at what this number of arrangements looks like. Then, this loop cannot use I. That j is used above. So it doesn't matter if you repeatedly use j below. If you're worried about problems, you can also use k instead. Next, just like the above, output our data. It's all right with or without parentheses, because we only have one line of item in the loop. Then change a new line after the loop is ended. At the end, we output it again, the real sorted result. The same way to make the loop. Exactly the same as before. And I just made a typo. Here I used k. Let's execute it and see what its status is. Here, it says I missed a semicolon. Okay, I found this missed semicolon. Okay, it will display its execution results. Let's take a look at what it looks like. In the beginning, we swapped two items that were closer, so 55 and 23 are swapped, then 55 and 87 are next. And it will not move, so 55 stays here, then the next one will be 87 and 62. Then we'll swap, so 87 will be swapped to the back and 62 to the front. Then there are 87 and 16, so they will swap. So 16 will come to the front, 87 will go to the end. This is the first sorting. Put the largest one at the end. Then, next sorting, 55 and 23 will not move, 55 and 62 will not move, then 62 and 16 will move, so 16 to the front and 62 to the back. Then the second largest one will go to the back. So next sorting, 23 and 55 will not move, then 55 and 16 will move, so 55 goes to the back. This is the third largest one. Sort again. 23 and 16 will move, so if 16 comes to the front, it will be done after sorting 4 times. This is the characteristic of the bubble sort algorithm. So the final sorted results is from small to large, 16, 23, 55, 62, 87. Everyone look at this again. If you still do not understand, you can pause and then write. Go ahead and finish this problem quickly. Select Sort algorithm. Let's take a look at the Select Sort algorithm in sorting and search algorithms. This problem expects us to use the Select Sort algorithm. Sort 5 numbers of 55, 23, 87, 62, 16, ascending from small to large. In the same way, we first build the format, or you can copy from the previous problem. After it is done, this problem is the same as the previous one. We are going to sort 5 data, so build the data array first. In the same way, let's display the prompt first. We know this one is doing select sort, not the bubble sort in the last problem. From the last problem, did you notice just show we wrote several times? It is actually a little troublesome, so we use functions to do this exercise for processing. Let everyone see the different ways of writing. For the function, we build 2. One is for select sort. In this function, we use the word select, and it is what we are going to send into the array, so it needs int followed by an asterisk, the position to send into the array. The other function is the function we use to show. In the same way, to send into an array. What about when we call, that is to show the original data? So, call this function of show, then call the function of select. Inside, we just put the data array. This is the area of the main programming code. For the function part, we can choose to write this simpler show. The show is that we are going to send into an array. So in the same way, we use data. Inside is what we have been writing just now. Use the for loop to show the data in the array one by one. Like we just wrote this one repeatedly for 3 times, so we just directly write it as a function that will be more convenient. Next, we are going to write select sort in the same way it sends into a data array. Then in the case of select sort, its main condition is, in the unsorted data, pick the smallest one. Pick the smallest or largest one. Put it in the designated position. This is the select sort algorithm. In the same way, we will use two loops for processing. So at the beginning, we start I from 0. Then all the way to I less than 4, I++. Then we will set a position. Its position starts from I. Then let's see if there is something more suitable than I to be placed in this position of I. We start looking for the next item of I to see if there is something more suitable than I to be placed in this current position of I, all the way to the end. Here you can see that I is only smaller than 4 and j is smaller than 5 because j must be equal to I plus 1, so I can only be up to the 4th one. The 5th one is for j. And what we are doing is to sort from small to large. So every time we're looking for the smallest one that hasn't been sorted yet to put it in the place we want to arrange. So as long as you find there is anyone after that who is smaller than the number of posts, smaller than the number in that position posts, we will change this one to j, so that we can find, in the unsorted ones, which position has the smallest number after all. After finding it, we will swap. In the same way, use the trigonometric substitution to swap I and the data of posts. To be able to swap the smallest one that hasn't been sorted yet to this position of I. Then if I itself is the smallest one, and posts is equal to I at the beginning, so swap I with I itself, then nothing will be swapped. This won't be a problem either. After swapping, because I have to show it every time, this time show is much simpler. We only need to first display a prompt text. We are at which time, the result of which time, use the show data just written to show the data. Let's execute it. Then, in the same way, you can also be outside the for loop. Make a final result, or write it in the main programming code. The final result of show is the same as the one of bubble sort algorithm a while ago. We can write more for the results after sorting. In the same way, it is very convenient to use show data then. Let's execute again. We can take a look at the starting original data. Then we just sort the ones here that haven't been sorted yet, find the smallest one, and then swap with the one in the frontest position. So 16 will swap place with 5. Then find the second smallest one. This one is not sorted yet. The second smallest one is 23, so 23 is at this place. Then find the unsorted part in the following part. The smallest one is 55, so put it in the place of the third smallest one. Next, 62 and 87. 62 is the fourth one. Put it in the fourth position. After sorting the first 4, the last one is of course the largest one, so it does not need to be sorted specifically. So we know the result of the sorting. That is from small to large, 16, 23, 55, 62, 87, like this. Everyone can look at this again. If you have not finished writing yet, you can pause and write this problem. Insert sort algorithm. Let's take a look at the insert sort algorithm in sorting and search algorithms. This problem expects us to use insert sort algorithm to take these 5 numbers 55, 23, 87, 62, 16 to sort in ascending order from small to large. In the same way, let us first process all the formats. After it's done, let's do this problem in another way. We let the user input data in this problem. For the user to input the data, it is more troublesome when the user inputs every time. How much data should be input? We are not sure. You can also let the user input the data he wants to input first. After inputting, then do the processing. That's okay too. Or we are the user and we input the number of data. If there is a change, we write 5 here directly, and many things will be changed later, maybe linked to 5. So we can use the method of define. To define this size 5, in this way, the size of this one will be 5. Then we just need to change this side. We can change to 10 to input 10 data, change to 7 to input 7 data. In this way, there are many related to size later. You don't need to make changes one by one. It will be more convenient. Then we will let the user input the data. Then it can show what the data you input is. In the same way, we give the user prompt text. Here is the insert sort algorithm. Then here, it is slightly different from the previous one. It's what he input. How to input the data? Here, we also use the function for processing. So our current function, in addition to the function of sorting insert, there is also the show data function just displayed. Add one more input function. Input array. ARR is the first 3 letters of the array. The front is the part of the array. The following is the length of this array. So for this input, we just put data. And after that, we put size. If we want to change the number of data, it would be more convenient that we don't have to change each one. Forget the semicolon again. Then we can show data. Then do the insert sort algorithm. Finally, you can do the same to show the final result after it is sorted. Then show again. Next, we will complete these 3 functions. Let's start from the simple one. Let's first do show data that we just did, so everyone should already know. Remember how to do it? Just use this for loop. Then pay special attention not to directly write I smaller than 5. We write I smaller than size. This is also a part where size is used. That's why we want to define directly. Not every time you want to change, you have to change everything related to size. This way is very troublesome. Okay, this big parenthesis can be kept or not. I will keep it this time. This is our show data. Next, the simpler one is the input. Let's write the input. For input, it is this input. Here, we just give it a code name, lowercase size. For input, we need to input 5 data. That is the number of data of size. So it is I equals 0, then I less than size, I plus plus. Then we can tell the user, please input the number of data and give a little prompt. Then here, we have a space before and after to make it look clearer. After displaying the prompt, let the user input. Let's execute it. The insert here has not been completed yet, so it won't let me execute. Then I first write an empty insert. Here, please input the first element. We will input 55. Then input 23, 87, 16. It's okay to input the wrong one. We will input the right one later. It will be the original input array and the sorted result. Because we have not done the sorting yet, the upper and lower two are the same, but this is the way we input. Next, we are going to write the sorting. This time we are going to use the insert sort algorithm. How to write the insert sort algorithm? Simply put, the insert sort algorithm is to sort the data that has not yet been sorted, pick it out, and put it in the proper place in the sorted list. We may have some data in the front which is already sorted. Assuming the first 3 have been sorted, then our new data might be this 54. I will take a look at this 54, put it in the front or back of 2. Put it in the front or back of 76. Find a suitable place to put this 54 in. This is the situation of the insert sort algorithm. Let's see how to write this problem. In the beginning, we also need to first build the loop. After the loop is built, we build a temp to temporarily store data. In this temp, we are going to store the I data. This is the data we want to insert into. Then why does I start from 1? because no matter what the data is, you can always assume that the first one has already been sorted. As the first one has been sorted, then see the second one. It should be put in the front or the back of the first one. After it's done, these two are sorted. Look at the third one, put it in the front or back. Look at it slowly. So our first one can be without moving. That is, the 0 data does not need to be moved. Just start from I equals 1. Next, we set up a variable j and make it equal to I minus 1. Why is it equal to I minus 1? We just said that these sorted data, then there will be unsorted data. This is the 1, assuming that the first 3 are sorted, so now I'm going to sort the fourth data. The fourth data is when I equals 3. Then we let j start from I minus 1. That is, starting from the data in the front, then slowly look forward until the first one, and then it will stop. Then look forward, see if it is placed in the front or the back of it. Keep looking forward until you finish them all. When looking forward, we can use while, because we don't know when it will end. But I know the condition of end. That is when I is larger than or equal to 0, and when temp is smaller than data j. J is larger than or equal to 0, and temp is smaller than data j. I will continue processing and leave until this condition is not met. Then what should I do? My way of processing is to make j plus 1 equal to data j. Then let j move toward the front. What does this mean? J plus 1 is equal to data j. It is to put my data backward. Assuming it's random like earlier, sorted items, I will put a 19. Then 67 is larger than 19, so I put 67 toward the back. I will have one more position, put 67 toward the back, and 54 is larger than 19, so I put 54 toward the back. Like this, put until I find that 12 is not greater than 19. My condition is no longer met, then I leave. After leaving, we can make the position of data j plus 1 equal to our temp. That is, the position we want to insert is equal to temp. In this way, 19 can be inserted into the position we want. The last is to show what is the result of the number of sorting. Then show data. Let's execute it. 55, 23, 87, 62, 16. So in the beginning, it was 55, 23, 87, 62, 16. And for the first time sorting, I will take 23 and 55. In the beginning, 55 was stuck in the first sorted position. Then 23 is smaller than 55, so I will insert it in front of 55. Then I look at 87. In the case of 87, it is larger than 55, so it stays in this position. Then look at 62. 62 is larger than 23, 55, and smaller than 87. So it will be inserted in the middle position between 55 and 87. Finally, look at 16. 16 is smaller than 23, so it compares in order with the ones toward the front. And it is inserted at the very front. This is our insert sort algorithm. Everyone can look at this again. If it is necessary, you can pause and then write this problem. Okay, please finish it. Linear search algorithm. Let's take a look at the linear search algorithm in sorting and search algorithms. This problem expects us to use linear search algorithm. Search in the sequence of numbers 3, 7, 14, 20, 23, 32, 41, 44, 56, 57, 73, 89, 93. In the same way, let us first process all the formats. Next, we're going to search. Next, we can build our data array first. And this string of data is very long. I will copy it. To build this array, then we can output. What does the original data look like? Because the data is very long, we change a new line to do the output. We'll be able to see what it looks like more clearly. Or you don't need to change a new line. It's up to you. There are a total of 13 data. So we output with for loop from 0 to 13. Remember to change a new line at the end. Let's take a look first. What will be the result of this output? After this output, we can see the original data. Then output the data in the next line. But here you can see that the last one, 93, has a comma. This thing is actually a little bit strange. Of course, the answer given by the teacher is like this, but I personally don't write it in this way. That is, we can only go up to 12. Then we will output the final data before changing a new line. If you execute it this way, you can find that the end of the last one, 93, will not have a comma. It looks more normal. Then everyone can refer to it. What's next? We just let the user search. You can input, ask the user to input what data he wants to search. Then let the user input. Then we are going to first define this input. We use search to build a variable. Let the user store the input in this variable. Then we will perform a linear search. Then, to find out the result of our search, we also use a variable to store the result. Use answer. We store the result in answer. Then judge the result and its condition. To see if there is any data found. How to judge? Let's first write the function for us to search. Let everyone know better how we judge. This search function will return a number at the end. It represents the position of the data. The returned result is stored in answer. So we just call this function to send my data in serial. Then I put in what I want to search. Then judge. Before judging, let us look at how to write this function. This function is linear search. Linear search is very simple. Just read from beginning to end. Put our data and the object we want to search. Then use the for loop to run from beginning to end. If found, if our iData, it is equal to the target we want to search, it means we found it. Its position can be returned. Its I position, if it is not found, we return a -1. Because the position of our array is from 0 to n-1, 0 to n-1. Therefore, if we return -1, it means we did not find it. This one is the way of writing programming code of linear search. Searching it from beginning to end is very simple. Then judge in our main programming code what we want to judge. You can judge that when answer is -1, it means it was not found. I can show that the data is not found. Then it can say that which data is not found. So, show the search for the data not found. If it is not -1, it means that the data is found. We can show where the data was found. Because the part of the return is I, it is in the place of 0, 0 to n-1. However, when we look at it, we usually do not look at 0, 1, 2, 3, 4, 5. We think 3 is the first and 7 is the second, and do not think 3 is the 0 one. So we can make this answer +1. This way, the user will understand it better when looking at it. Let's take a look. What will its output look like? Now, we just need to input what we want to find. Let me first find one that does exist. We find 41. We can see that 41 is found in the 7th one. It takes 3 as the first one. 1, 2, 3, 4, 5, 6, 7. 41 is found in the 7th one. Let us execute it again and put one that does not exist. We put a 100. It shows that data 100 is not found. This is the method of linear search algorithm. Everyone can look at this again. Okay, please complete this problem. Binary search algorithm. Let us take a look at the binary search algorithm in sorting and search algorithms. This problem expects us to use binary search algorithm. Search in the sorted sequence of numbers below. Pay attention that it is a sorted sequence of numbers. The main programming code of this problem is exactly the same as the linear search of the previous problem, so we can first copy the previous part. Then we can check the data it requires. They're exactly the same, so the data does not need to be processed. Of course, our function will look different. So in the part of our function, please change it to binary search. For binary search, it will need 3 parameters. We will talk about what these 3 parameters are in a moment. The linear search used below, please change it to binary search. The first parameter is our data. So data. The second one is the data we want to search. And the third one is the length of this data array. You can put in 13 directly or use the program to help you calculate. Use size of data. Then remove size of int. It will help you calculate, and the length of our entire array will be 3. So the main programming code is almost the same as the previous problem. Everyone can take a look at the main programming code first. Then we will focus on how to write the binary search. Okay, let's look at binary search next. The part of the binary search is the return in the end. Return if it is found. Return that place. Return -1 if not found. The 3 parameters in it are the data and the target we want to search respectively, and what is the length of the entire array. Then, how to do it. Binary search has a very important point. That is, the data must be sorted data, because we will look at both sides and find the data in the middle. Take a look if the data I found is larger or smaller than the data in the middle. For example, this group of data we have now, the front and back positions are 3 and 93. Let's write down its number. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. After the number is completed, we can see how to find it. Assuming we want to find 30 now. Then we start from the front and the back to find its middle part. Binary search is to divide in half every time, then follow by looking at the first half or the second half. In the middle of 0 and 12, we should have 6. This part of 6 is 41. 41 is larger than 30. So you think 30 should be in the front. Because we are in a sorted condition, it will be the part in the front. So at this time, we will make the upper bound become 5. The upper bound becomes 5. Because 41 is definitely not, I just let its upper bound become 5 and then continue to search down. So my lower bound will be 0 and my upper bound will be 5. Then go find to see if the data we want is in it. Between 0 and 5, there are 2 and 3. We usually discard it unconditionally and take 2 as the middle part. So it can be found that 14 is smaller than 30. So we know that it will be behind 14 to have our answer. So we will set the lower bound to 3. To continue looking from 3 to 5 this way, the middle value from 3 to 5 is larger than 30 or smaller than 30. Keep looking, looking, looking until it is found or really not found. Then what is not found? Let's keep looking for it and we can know. Now the lower bound is 3 and the upper bound is 5. So between 3 and 5 is 4. The part of 4 is smaller than our 30. So it should go toward the back. Then we can find that our lower bound should be set to 5. So the upper and lower bounds will both be 5. This situation is still okay because it is possible that this one is actually 30. Then our upper and lower bounds are both 5. When compared again, it is found that it is 32. It is larger than 5. So 30 should be in the front. I will set the upper bound to 4. But this time, a strange situation appears. Our lower bound is 5 and the upper bound is 4. Isn't this wrong? At this time, I know that I can really not find this item. So, as long as you find that our lower bound is larger than the upper bound, the lower bound is actually larger than the upper bound. That is, the data cannot be found. We can return -1, okay? Let's write it. How to write this operation into programming code. First of all, we set up our lower bound and upper bound. Low will always start from 0. Then high will be n minus 1, because n is the length of the entire serial list, the length of the entire data, and we know that the last one will be n minus 1. As long as our lower bound is less than or equal to the upper bound, the search can be continued. Once it does not match, it means that we cannot find the data. So, if the condition matches, continue the search. Once it does not match, we return -1. So long as it jumps out of the while loop, it means the data is not found, then return -1. Here, we are going to look at the middle position between the upper bound and lower bound. So I add the upper bound to the lower bound and divide it by 2. In C++, you write divide by 2. Because we are all int here, it will unconditionally round it up for you. Next, we will look at our median value. Its data is in the middle position. Is it the same data that we want to find? If it's the same, it means that we found it. Great! We can return its position. Return the median value, its position. Then if it is not found, we have to judge it. Search toward the front or toward the back. So we are going to take a look at this data of our median value now. Is it larger or smaller than the data to be searched? If it is larger, it means that we want to look toward the front in order to find our data. For example, we want to search 30, but the median value I found, it may be 46 or 44 or something like that. Then we have to look toward the front to find the data. Set the upper bound to the median value -1. Go toward the front to find this data. If it is the other way round, it is smaller. The part of the median value is smaller than the data to be found. For example, if we want to find 30, the median value is 7. I just go toward the back of 7 to find a solution. So I set my lower bound to the median value +1. And continue searching. Repeat searching continuously. We can then find the data position we want. If it happens that the lower bound and the upper bound are reversed, it indicates that it really cannot be found. Let's execute it. Let's find one that can be found, 14. It can know that I found 14 at the position at the third data. Then let's find one that cannot be found, like the 30 a while ago. It is the condition that cannot be found. This one is the way of writing programming code of binary search. Then the way of writing this is much faster than linear search, because it searches by dividing by half and dividing by half every time. Unless it is the linear search, which finds the data in the very front, otherwise binary search is usually faster, especially when your data volume is super large. Then binary search can be used. It will be much faster than the linear search. Try solving this problem on your own.